All right. The floor is yours.
Okay. Do you hear me?
Yeah, perfect.
Okay. So, well, the title is not the one you just told. I will give this talk tomorrow, session 8. But now I am going to speak about well, you see the title of my talk now. In what sense can you say that movement precedes space and time? Well, so I say hello to everybody and to my colleagues in thermodynamics from different countries. And first of all, I would like to thank Ram Pudel and all the Thermodynamics 2.0 group for their invitation and for their person. In my talk, I will try to make you understand how I am dealing with the trilogy of concepts: time, space, and movement. So as you see, the topic is very general, and it might be of interest to different scientific disciplines, including thermodynamics proper. Some previous speakers have briefly alluded to the time issue, to time arrow, to the nature of space-time, and so on. And tomorrow, as I just told, I will discuss specifically about thermodynamic and social sciences. Well, this is the outline of my presentation. If I want to summarize the heart of my point, I would say that movement precedes both space and time that are derived from it. To make you grasp this idea, we could spend much time discussing epistemological and philosophical issues or studying the working of clocks in relativity theory. I prefer here to propose a kind of thought experiment by use of some images. This will be section 2. We will derive some general consequences, section 3. Well, we will then skip section 4 to 7. They are addressing issues in epistemology and philosophy of knowledge at stake in my point. When you are dealing with time and space and movement, the matter is not merely to build better clocks, better rulers. The matter is to discuss what are we doing when we use such and such word in correspondence with reality. Well, we will make a special stop at section 6. Movement precedes both space and time. Then we will go back to physics. I will not go in detail, I will not discuss in detail the consequences of my point of view in physics in the large. I will just list them. However, I will give you some words about my proposition of a modified gamma factor for the Lorentz transformation. I presented it at the last biennial conference of the French Physical Society 1 year ago. I would like to insist on the fact that in order to make progress in physics today, it is imperative to make a detour through epistemological and philosophical reflection. This is a rather long and difficult work, and we need to devote some time on it. But it is essential first to try to understand the point of view I propose, or I would say at least as a game, even if you do not agree. Then everything can go faster. The applications are numerous, and I would say a word about it. Well, unfortunately not enough because I do like equations. So let me present my vision of time. Well, in my understanding, time does not exist. It does not exist alone as an independent substance of the world. It is abstracted from the world, from which it cannot ultimately be separated. Specifically, for me, time is abstracted from the movements in space of the material entities in the large. However, when we abstract time, we construct an object which has pragmatic effects that can be studied and discussed. The understanding of time is the understanding of the abstraction of time. To avoid too many words, I make use of what French philosopher Bergson called the philosophical intuition. I call it the comprehensive or relation-based thinking, often made of images that come in composition, not in opposition, with the discursive, disjunctive, substance-based thinking, mostly made of words. For issues that concern us, we especially need both. Let us then have, as Bergson also commented in this context, an artistic approach trying to grasp at once, as a whole, the objects of thought. So, how to speak of space and time? Let us start by noting that neither space nor time exist by themselves. They are based on the phenomena of the world. Let us look at this landscape, as other people have done before us. Space, some benchmarks borne by the mountains as geographical markers that are planted there as a set of points connected by the GPS network. Time, as the sun going across the sky, or as the clouds, or as discards. Their movement allows us to classify, to sequence the events. When the cart was here, I did this. When it was there, I did that. Or another landscape, another vision of space and time. A mountain allows to build space. Ocean waves allow to build time. Their progress serves me as a clock. In what we have done, we feel that we can look at space with no need to look at time. But this is not the case. And this is the heart of my discourse. Time and space are not only related to the world, but also relative to or in relationship with each other. For a proof, a change of scale is necessary. Let us think through tens, hundreds of millions of years. The stone wave is then strictly identical to the ocean wave that we saw a short time ago. It moves like it and can serve us to measure time, which served us to define space, now serves us to define time. And we can think of other stone waves like that of the Sainte Victoire near to Cézanne in the south of France. But conversely, if we live at the scale of nanoseconds, the sand in the hourglass does not move for the duration of our entire life. The ratio of the nanosecond to the second is the same as that of the second to the century. The grains of sand may serve us as a distance gauge. What was used to set time is now used to set space. Over short time scales, the relief of the water is similar to the landscape we contemplated a while ago. We can pinpoint its irregularities to locate us. Well, you will say, this is a beautiful allegory, but at some point we will be able to stop and say, here is space, here is time. Well, no. In this infinite transhumance that in a way transforms time into space and space into time, we are inside the world and we cannot bring rulers and clocks from outside the world to measure it. We can only compare the phenomena to the other phenomena, and from this comparison, build space and time. So if we stop, it is not that we would have found a pure time, a pure space, with words defined in advance as waiting to be used. But this is because we are tired. We stop at a scale relevant to the phenomena that we want or that we can study, and make a provisional sharing between what does not move too much, we build space on it, and what is defined by comparison and that moves more, and we call it time. But we're not sure of the ultimate meaning of the very words we use to talk about them? Well, of course, all this would need longer developments. Here are some first general consequences. Time and space are of the same nature. They are separated thanks to the multiplicity of relationships and the sharing of them in two classes, defined in opposition to each other. We use a relation-based thinking that needs to be stabilized by a decision left to free will, that of a judgment by which we choose within the same thought a declared constant immobility, the spatial frame, in composition with a declared also constant mobility, the standard movement to define time, whether human or offered by the physical world, on which our knowledge builds and loops. The postulates of relativity theory are there. There are hidden conceptual loops in this process. A speed is defined by comparing two movements, one of which is selected as a standard. There are no longer rulers nor clocks, but only a standard movement. So we do not talk about the speed of light because light defines both the standards of space and time. Or we can say that the speed is unity, or merely say that light is the standard of movement. Initially, times are plural, as are spaces, supported by the multiplicity of local movements. All is not solved. Of course, the mystery of time is shifted, but we have new keys to read many issues from humanities and to social sciences to physics. Well, so I will skip, as I said, the following section about the abstraction of time. I will not discuss either on some epistemological points we already used in the preceding, and we may make a stop to summarize in another way how we consider that movement precedes both space and time. The movement expresses the first relationships to the world of the knowing subject. These first relationships are shown before the words. The words later accompany the supposed qualities attributed to the objects, but they are hypotheses hidden there. Let us explain this again. We start by showing a movement. For instance, the movement of this man in Paris, or the movement of my hand in front of you. If we want to describe this movement by words, we are tempted to say the position of this man in space is variable with time, or the position of my hand with respect to the space of this room is variable with time. But we are wrong. It is too early because we use the words space and time too quickly. Actually, we do not know what space means. With the poets, we could, for instance, say that the Eiffel Tower moves, or this room may inflate during my talk. The only thing we know of is the comparison of two movements. We may then say, let us decide that the Eiffel Tower does not move. We build space from this decision. By comparison, the movement of the man may be taken as a standard for time, but we ultimately do not know. It is only after we have decided these conventions and in a way define the words space and time that we can go back on our steps and give a name on what we had only shown. The movement is the variation of a spatial position with time. But we must stress that behind this phrasing, a fundamental undetermination is hidden and a fragility is there. But this convention is useful and strong by what it allows, a large communication and the provisional building of our knowledge. The foregoing lines are a way to link the relation-based thinking, images, designations, and the discursive rationality. Inside relational rationality, the entities are defined from the other entities, and when always start with a specific situation. Well, the next slide I will also skip. I will not comment it. It is a kind of symbolic picture to stress the need for a paradigm change. But it is now time to go back to natural sciences. This section, I am giving you my own feeling. I call it my reflexes about some statements I read in current research in physics. Of course, this is open for discussion. I will go rather quickly over this section. The first reflexes relate to time, space, physical laws, quantization, and the theory of relativity. Here I still discuss quantization and relativity theory and going to thermodynamics. Well, tomorrow I will speak more about thermodynamics. Here you will find some comments on what is called proper time in relativity theory and the search for a local theory. And there some comments about energy, universal constants. All these statements may be considered at the start for new researchers. And generally speaking, the working of the equations in natural sciences must incorporate a number of points we have put forward. Well, I have started some research by myself, and this is a list of the different issues that can be discussed with the space-time movement understanding I have just presented. Each of these items would need several hours to be presented with some details. And there are very numerous practical consequences. And as I pointed out, there are also many implications for the humanities and social sciences. They are the subject of seminar papers, written text, and various collaborations. I just list them here. Well, but it is interesting to make a stop on one consequence that I have presented recently at the French Physical Society, just to show, well, the other items could all show it, that my vision is not only philosophical, but it has technical consequences for the physical equations. One of the consequences of the above discussion is that the clock is a point of view on a movement. There is no scalar time flowing everywhere. And the same assumption must be made about the constancy of the standard movement as seen from different point of view or in different reference frames. And so I have tried to articulate this understanding building of time with a writing of the Lorentz transformation in relativity theory. You may have heard about Lorentz transformation is the basis of relativity theory. In the first figure, figure A, the situation described by the classical relativistic approach is presented. Two reference frames, R and R prime, are presented, and their origin is O for R and O prime for R prime, and these two reference frames are moving to the relative speed V. O prime equals V. Each of the two frames is equipped with a clock. You have two clocks, one clock in R and one clock in R prime. The clock are called H and H prime. Well, in French, clock is horloge with a H. We consider also the displacement of a photon, P, and assume that its displacement speed is the same as viewed from R and as viewed from R prime. This is the second relativity postulate. This photon can move in all directions. This possibility has been represented by the wave surface centered on O prime. It is a two-dimensional circle. Let us ask again, what is a clock? we would like to know what is a clock. Well, so in figure B, we have opened the clocks, and we discover that each clock uses the movement of a photon. Well, these two photons are pH and pH prime, because we use the standard atomic clocks of today. We now have three photons, pH, pH prime, and P. So the question is, what kind of hypothesis should we make about the first external photon and the two photons inside the two clocks? Well, if we want our approach to be consistent, we must take the same hypothesis for the three photons. And so in figure C, we unify the approach, being led to postulate the same behavior for the different photons that are now one at the conceptual level. In order to have clocks needed to measure time in both frames, one must particularize a photon that will serve for both time in R and R prime, and they embody the second postulate of relativity. Well, the two clocks H and H prime, as defined in figure A, are destroyed, or they are forgotten because they were fictions. So we can do now some geometry as defined by comparisons of pieces of movements. The two frames R and R prime as relative movement at speed v, as I said. We have only one clock photon, P. The angle between v and the photon is in R prime is delta. The velocity modules ratio is beta. It is the ordinary usual factor in relativity theory. There is no substantial time, no space, waiting to be dilated or contracted. No influence of movement on the passage of time, which does not exist. We only see movements compared to each other. During the time or during a piece of movement that the frame R prime moves from Vt, the photon moves from Ct in R and from Ct prime in R prime with the same C factor. This is the second relativity postulate again. By writing the relationships between sides and angles in the O prime triangle, we obtain. This proposal makes the relativistic approach consistent. The meaning of relativity factor is extended, making it depend not only, as in the standard case, on the ratio V over C of the velocity modules, but also on the angle between these two movements. The relationship proposed makes it possible to find in the same framework various transformations already known, including that of Lorentz. As I told, this general approach allows for new insights into a range of issues under discussion. Here it suggests new experiments to study temporal distortion between reference frames in relative motion. An angle of time. Well, we must conclude. We are approaching the end. Well, to conclude, I dare to tell you about this book. Well, unfortunately, it is written in French, that has just come out, and in which I go back at length on the points I have made here. I chose a literary genre mixing dialogue and phantasmagoria in the imaginary land, Neverland, of Captain Cook, the enemy of clocks. I examine a plurality of facets in the different sciences, both human and social, and so-called hard sciences, whose boundaries I revisit. I allow myself to dialogue with various scholars without forgetting poets and artists, nor the inhabitants of the Neverland. Well, I thank you for your attention.
Thank you very much, Dr. Guy. If you guys have questions, please unmute yourself and ask the question.
Hi. That was a fascinating talk. I had So I had a question about your notion of time. So if time can be, I believe this was in one of your slides, if time can be abstracted from sort of movements and relations in the world, would it be fair to say that it can't exist independently of human minds? That's sort of like the first question. And then a related question is, could we not say that time is, in some sense, independently of human minds, could be something like the constraints that nature piles up along the way as change happens? I mean, you know, one version of this is the second law, but of course it's broader than that. And what I'm talking about is, you know, imagine a day. You know, a day today is 24 hours, but 600 million years ago, it was 22 hours. So the day is getting longer because tidal forces are dissipating the planet's rotational kinetic energy. And it's in that sense that, yes, there are cycles in nature, but they accumulate constraints over time. And maybe in that sense, we might be able to speak of time as sort of existing independently of human beings. That's not to deny your notion, but no. I just, it's a philosophical question more than anything else.
Well, yes. Well, you have asked many questions. In my understanding, yes, we have no time independent of our human construction. But of course, there is the nature is made of movements, and of course, I would say that these movements in nature are the reason why nature evolves and so on. But I would say that time is a very useful construct, and of course, I also use the word time in many times in my life. Is a construct, and when you have done a construct, it has pragmatic effects, and you can study the construction you are doing, but it does not refer to a fundamental, to a substance of nature by itself. But it is useful, of course, to use time, and but it is a construct, and what I would say that what is primary for me, it is the movement, and you can discuss all what happens in nature by movements, and you know that you have many cultures in the world. For instance, the traditional Chinese culture, they did not need to construct the concept of time, but they just discuss the movements they observe in nature. But what I am adding maybe to this idea is that when you are doing this, both space and time must be discussed together, because otherwise you will have epistemological problems. And well, you still have, but well.
If I can interject here and just say, Bernard, I really enjoyed your presentation. The way I view time is basically homeomorphic to entropy. One cannot exist without the other. And in fact, this goes back to the famous dialogues of the ancient Greeks philosophers between Heraclitus and Parmenides. And in fact, to me, I also believe that just as there is a time dilation principle, there is also an entropy dilation principle that one can probably also show too. And in fact, that it's relative to what is moving to what is stationary, entropy changes accordingly, just like time changes accordingly, and that entropy is not actually a Lorentz invariant as originally thought by Planck and Einstein.
Yes, I did not discuss about entropy, and the previous man asked me about entropy. Well, what happens? Do you still hear me?
Yes.
Yeah.
Yes. Well, so for me, the understanding of the second law, I'm trying to understand the second law by means of movements, and not merely with time, because I think the link between the second law and time is too tight.
It's 12 o'clock.
It must stop, maybe.
No, you're good. Please keep going.
Yes, I mean I think the second law must be discussed not only with time but with movement, time and space together. And when you read the equations for the second law, the entropy production and so on, you always have spatial gradients. So I cannot separate spatial gradients from the time derivative. And if you agree with this, you will have another understanding of maybe, it is, I do not, maybe a deeper understanding of the second law, another understanding of the second law.
Agreed.
Thank you.
There are few more questions on the chat that popped up there. If you please would like to unmute yourself and ask, or I can read it if you.
Can I speak up, or if you want to call out, please do. Otherwise, I'll ask my question.
No, please feel free. We have time. So.
Okay. It seems to me that the argument you made for time and space being actually derived from movement, a similar argument can be made, and I think should be made, I have tried it, in economics actually, about in the standard economic theory, we assume in choice theory and decision making, we assume that people have preferences and they may have some subjective probabilities, and then their choice or behavior arises from their preferences and subjective probabilities. I think I like your argument because I think it's exactly the opposite in economics too. The only thing we observe is choice or behavior of individuals, and then we work backwards to choose, to decide what infer the preferences and probabilities that might be mutually consistent with each other. And they are only, there's only one degree of freedom there. So I see a great deal of parallel with what we do in economics and the argument you made about in physics. I don't know if anybody would care to comment on that.
Well, I'm not so competent in economics. Well, I'm not sure I fully understand, but well, maybe we can speak later about it. But I would say that when we, of course, when we discuss time and space in social and human sciences, and maybe also in economics, we must be very careful because in physics, maybe it is simpler in some aspects, in some point of view, but for the human and social sciences, it may be complicated, more complicated, because the human has his own time inside him and so on. And yes, you say we just see the choice, and then we go back and try to understand the preference of the subject. This is what you say. Well, but when I discuss time issues with my colleagues from human and social sciences, I think they have built something which has a meaning, a cultural meaning, and there are many steps hidden behind that.
How would you define matter in concepts of space and time?
Pardon?
Matter, material, stuff.
Matter. Well, of course, we need matter in the large way, including photons and so on. To the space and time are constructed by the phenomena that affect matter. The way we understand matter, the way we measure and so on. it is another way to speak of space and time. I did not dissociate, do not separate matter, space, and time, because time and space are built from the real, from the matter. I don't know if I understand, fully answer, but I do not speak of space-time by itself. Space-time is always a comparison of phenomena involving matter.
Yeah, and I think this this notion of movement being fundamental has also like parallels in modern theoretical physics. For example, the vast majority of the mass energy density of a proton is just quantum fluctuations, right? It's just the gluons and the quarks. It's just the quarks exchanging gluons amongst each other. So, so yeah, that goes to your point.
But in any complex system, if you're talking about a social system or a galaxy, you have to be talking. Time is part of it. Time is captured in the field processes of the system with the repetitive cycles, and then there's the conservations that are across mass, energy, and movement. So you have to. You can't say that there's no time. It's that time is caught in the physical processes themselves, no matter what level you're talking about in a complex system.
Can I ask a question?
Yes, yes.
Yeah, actually, I give a presentation on Wednesday where time and thermodynamic state index are linearly independent axis. But if the temperature is zero Kelvin, so there is no movement, then is there time?
Well, if you have matter and space, I would say time and space will be there both in a way, but because if you cannot think of points in space without thinking, or you do not hear me, no?
No, I hear you.
You cannot think of points in space without thinking of the movement which relates these points in a way. So maybe I am at the limit of what I can say, but I would say that movement is another way to speak of reality. If you are speaking of a system which has zero temperature, you still speak of something about reality. And so space and time are both, in a way, they're both there.
I see. Okay, thank you.
Are there any other questions from the audience?
Well, okay. So thank you.
I have one quick,
Yeah.
the last one. So you have defined these variables to be a construct of some sort, and mathematically, if you think about it, you can have some kind of commutation relationship, or you can come up with a variable, an operator to rotate it in some ways, and that can reveal the hidden variable such as force. As previous one of the audience members said, there is this impulse or influence that that emerges out in the market, similar to the concept of that, right? So have you looked into this construct of having a mathematical operator which is basically rotating these variables, and what could that be possibly?
I'm not sure I understand your question, but in relativity theory, you deal with rotations. Is it what you mean? For the general Lorentz transformation, you use rotations. But what I mean is that when you are dealing with rotations, you must rotate, of course, the space coordinates, but you must also rotate the movements that define time.
Right.
And if you rotate the movements that are hidden in the clocks, if you rotate the movements that are hidden in the clocks that you did not see, if you rotate them, then it will give a better working of the equations, because maybe you know that in relativity theory, when you deal with rotations, there are sometimes some problems, and maybe you have heard about Wigner-Thomas rotation and so on.
Yes.
I have discussed this in some papers.
Yeah. Okay, cool. Well, thank you very much for your time, sir.
Thank you, merci, au revoir.
All right.
Au revoir.
All right.